Hello students, welcome back to C Rasayan. Here I will explain electronic movement in organic reactions and electron displacement effects in covalent bonds. 4 effects are there. Here I will explain inductive effect. Now first I will explain electronic movement in organic reactions. How to show electron movements. Okay. Now in organic reactions for bond breaking and bond making, electronic movement is taking place. The movement of electrons in organic reactions can be shown by curved arrows like this. Curved arrow starts from the point from where an electron pair is shifted and ends at a position to which the pair of electrons may move. For example, here movement of electrons are taking place from pi bond to adjacent sigma bond. So this pi bond is having 2 electrons. So 2 electrons are coming here to make one pi bond here. So now he see here pi bond is shifted here and here only one sigma bond is there because electron density is shifted here. Another way is Y is one atom. Here movement of electrons are taking place from pi bond to adjacent atom. Pi bond is having 2 electrons. One covalent bond means 2 electrons. So this electron density is shifted here on this atom. So what can we write? Here in place of the double bond, here now it is having single bond and it is having lone pair. So that electrons of the pi bond is now on Y atom. It is on adjacent atom. So these are all resonating structures. So this type of double-headed arrow you have to show. Another possibility is there. Suppose you are having lone pair on this atom. So here 2 sigma bonds are there. This lone pair of electrons can shift here. So what will happen now? We will get one pi bond here. So in place of single bond we are getting double bond. So now what is happening? From atom to adjacent atom, electronic movement is taking place. And movement of single electron is shown by fishhook arrow, means this one or this one, half-headed arrow. This is full-headed arrow, this is half-headed arrow. Electron displacement effects in covalent bonds are of 4 types: inductive effect, electronic effect, resonance effect, mesomeric effect. One by one I will explain. In this video we will do only this one, inductive effect. Now see, consider a carbon chain like this. It is having one lithium atom attached with this C1 carbon. You know lithium is electropositive. So in C-Li bond, which one is more electronegative? Between this carbon and lithium, carbon is more electronegative than lithium. So what will happen? So here partial shifting or partial displacement of sigma electrons towards more electronegative carbon atom takes place. So if partial shifting of electron density will take place toward this carbon atom, what will happen? This will get partial negative charge and this will get partial positive charge. So C1Li bond in this case is a permanent dipole. C1Li bond is permanent dipole. This dipole induces a permanent dipole in C1C2 bond. And since it is having partial negative charge, so what will happen? It will repel electron density towards C2 and C2 becomes slightly negatively charged. So we can write delta, delta minus, magnitude of which is smaller than on C1. And here we can write this is smaller than this one. Once again, partial negative charge, it will repel electron density towards C3. It will have delta minus charge. It will repel also electron density towards C4 and it will have this charge. And obviously order of partial negative charge is this one. In this way, the induction of negative charge may transmit down the chain, but the effect decreases with the increasing distance from the starting dipole. The effect is decreasing and you can see value of partial negative charge is decreasing down the chain. Arrow means electron displacement is taking place in this direction. Here in this direction, here in this direction, here in this way. In fact, inductive effect is important up to C3. It's up to 3 atoms and dies down beyond the 4th atom. Now what is inductive effect? The permanent dipole. This is dipole. Here since delta minus is having more value than delta minus. Okay. This one is having more value than this one. So the permanent dipole induced in a bond by another directly along a chain of carbon atoms within a molecule is called inductive effect. In fact, inductive effect is important up to 3rd carbon atom in the chain and it dies down beyond the 4th atom. So till this it is important. After this 4th, here also it's very less and after that it is meaningless. It is discovered by scientist Ingold, so it is called I effect or inductive effect. I effect or inductive effect. In short, I effect. Magnitude of this effect is inversely proportional to distance. We have seen already. This is permanent effect in the ground state of a molecule and it operates through single bond. You can see here. So it is called permanent polarization of single bond. It is called permanent polarization of single bond. Now let us take another example. Consider the following chain. Here 4 carbon atoms are there in the chain and with this carbon one fluorine atom is attached. You know electronegativity of fluorine is higher than carbon. So what will happen? Here sigma electron pairs. These sigma electron pairs get partially displaced towards fluorine since it is more electronegative. And here what will happen due to that? Fluorine will get partial negative charge and carbon will get partial positive charge. So polarity is there and whether reagent is present or not, that polarity will always be there in the molecule since inductive effect is permanent effect. Now since this carbon is becoming electron deficient, so what will happen? This shared pair of electron will be pulled towards this carbon. So this carbon will become slightly this means it is having partially positive charge. Once again similarly this carbon will have this charge. Because it is electron deficient, it will abstract electron or it will pull electron density towards this carbon and this carbon will become delta plus and the magnitude of this partial positive charge will be decreasing like this. So what is happening here? Magnitude of inductive effect goes on decreasing with increase in the distance of the carbon atom as we have seen here also. So due to electronegativity difference, here polarity is developed. Due to development of this polarity, this bond is becoming polar. Like that way, inductive effect is operating. This effect travels up to 3rd carbon atom. Here it is very small and then it will vanish. Now we will study what are electron withdrawing group, what are electron releasing group or electron donating group. Electron withdrawing groups are those groups which abstract electron from carbon towards itself. This F, it is electron withdrawing group. It is abstracting this electron density towards itself. Electron donating or electron releasing groups are those groups which donate electron towards carbon. Inductive effects are of two types. One is electron withdrawing inductive effect. This is denoted by -I effect. The atom or group attached to the carbon atom in the chain is electron withdrawing with respect to carbon. Now see, carbon and hydrogen, they are having comparable electronegativity. The decreasing -I effect of some important atoms or groups relative to hydrogen atom is this one. You have to remember this order. This is decreasing order of -I effect. So this one is example of -I effect. Another is electron releasing inductive effect or electron donating inductive effect. It is called +I effect. Here what is happening, the atom or group attached to the carbon atom in the chain is electron releasing. It is releasing electron towards carbon. Since carbon and hydrogen are having comparable electronegativity, here also the decreasing +I effect of some of the groups relative to hydrogen atom is this one. This is carboxylate, this is tertiary butyl, this is isopropyl, ethyl, methyl, deuterium, hydrogen. So here this one is example of +I effect. For alkyl group, magnitude of +I effect is proportional to size of the alkyl group. This is methyl group, this is ethyl, this is N-propyl and this is N-butyl group. Since the size of the alkyl groups are increasing in this direction, therefore magnitude of +I effects are also increasing in this direction. Now see, these are isomeric alkyl group. 4 carbons are there everywhere and 3, 4, 5, 6, 7, 8, 9. 9 hydrogens are there. So these are isomeric alkyl group. Magnitude of +I effect is proportional to number of branching. Here no branching, this is N-butyl group. Here 1 branching is there, here 2 branching are there. So magnitude of inductive effects are also increasing in this direction. Now here we will study about application of inductive effect. First one is to compare the stability of carbocation. We know neutral species are more stable. Groups having +I effect means electron releasing effect decrease the positive charge on carbocation. So we can say stability of carbocation is directly proportional to +I effect. And groups having -I effect means electron withdrawing effect increase the positive charge on carbocation. So stability of carbocation will decrease. So we can say stability of carbocation is inversely proportional to -I effect. Now see, this is tertiary, this is secondary, this is primary and this is methyl carbocation. Methyl groups means alkyl groups are having +I effect, electron releasing effect. So this will reduce the positive charge on carbocation by +I effect. So greater the number of such groups, greater will be the neutralization of the positive charge and more will be the stability of the carbocation. So here 3 methyl groups are there adjacent to carbocation. So this will release electron density in this direction. Here 2 methyl groups are there adjacent to carbocation. This will release electron density. Here 1 methyl group is there adjacent to carbocation. It will release electron density. Here no methyl groups are there. So obviously this will be most stable. So stability order is this one, decreasing order. You can say also greater the number of groups having +I effect, greater will be the dispersion of positive charge. Means positive charge is not localized. When this bond pair it is shifted towards this C+, what will happen? It will become positive. Here also it will become positive. Here it will become positive. So what will happen? Positive charge is not localized on one carbon atom. It is dispersed here, here and here also. It is dispersed here and here. It is dispersed here. So greater the number of groups having plus I effect adjacent to carbocation, greater will be the dispersion of positive charge and more stable will be the carbocation. Now next application is to compare the stability of carbon ion. Carbon ion means on carbon atom negative charge is there. Electron releasing groups means groups having plus I effect increase the negative charge on carbon ion, because if here is carbon ion, it is attached with electron releasing group. What will happen? Electron will be released here in this direction and electron density on carbon ion will increase. So negative charge increases means stability will decrease. So stability is inversely proportional to plus I effect. And if with adjacent position of carbon ion there is one electron withdrawing group, means group having minus I effect is there, so it will abstract electron density from this carbon, negatively charged carbon, and charge neutralization will take place to some extent and species will become stable. So stability of carbon ion is directly proportional to minus I effect. Now see, this is tertiary, this is secondary, this is primary and this is methyl carbon ion. So it is attached with here 3 methyl groups having plus I effect. So electron will be released in this direction. They will release electron in this direction. So negative charge density will increase on this carbon and species become least stable. Here 2 such groups are there. Here only one methyl group is there. Here no methyl is there adjacent to that C minus. So what will be the stability order? This is most stable. So stability is increasing in this direction, because on carbon, due to electron releasing effect of methyl group, means due to plus I effect of methyl group, on carbon negative charge density is increasing. That's why species is becoming less stable. Now see, between these two carbocation, which one is more stable? F, nitro, those are electron withdrawing group. Electron withdrawing group means these are having minus I effect. Electron withdrawing group. Now see, with respect to this carbocation, at the alpha position, means at alpha carbon, electron withdrawing group is attached. Here also with respect to this, at alpha carbon, electron withdrawing group is there. So position wise or distance wise, position or distance wise, both are same, because at same distance from carbocation, electron withdrawing groups, means groups having minus I effect, are present. Now see number. Here 2 fluoro groups are present, here 1 nitro group is present. So group wise, if I am giving this one as number 1, this is number 2. So number wise, 1 is having more number of minus I effect group and 2 is having less number of such groups. Another thing we have to see, power. Power means electron withdrawing capacity. Here these groups are having minus I effect, so we have to check which one is more electron withdrawing, which one is having more minus I effect. That is called power. So nitro group is more electron withdrawing than fluoro. So how we will decide which one is more stable? Just remember one thing, you have to give priority of distance, then number, then power. Since in 1, 2 electron withdrawing groups are present, so its effect is higher. So it will abstract more electron density and the carbocation will become less stable. So which one is more stable between these two? Number 2 is more stable. Now see, between these two species, which one is more stable? First we have to consider distance. Both are having minus I effect, here nitro and here chloro. Means it will abstract electron density from this species and the system will become less stable in both the case. First we have to see the distance. Here distance of group having minus I effect, it is less in 1. You see with alpha carbon atom nitro group is attached. Here with beta carbon atom with respect to the positively charged center, chloro groups are there. So distance will get preference, and though here two Cl groups are there, but since this will get preference, so what will happen? It will destabilize the system because it is having minus I effect more. So stability of this species is more. Now see, we are having 3 carbon ions. Which one is more stable, or what is the order of stability of these 3 species? Now see, these 3 are nitro, cyano, fluoro. All are electron withdrawing groups, means they are having minus I effect. Minus I effect will stabilize the carbon ion by neutralization of or minimizing the negative charge density. Distance wise, all are at same distance from carbon ion. So distances are same. Number wise they are same. All are having 1 groups having minus I effect. So number wise it is also same. And what is the power, means electron withdrawing capacity or minus I effect? Nitro is most, then cyano, then fluoro. Means nitro group will withdraw electron density in this direction, and there will be minimization of negative charge, and the species will become more stable. This is also having minus I effect. This is also having minus I effect. It will pull electron density. Since it is having highest power of minus I effect, so this species is the most stable one. So stability order will be like this. The power I have written here. Hope it's clear to you. Next application of inductive effect is to compare the acid strength. You can compare the acid strength between two acids. Acids means H plus donor or lone pair acceptor. Suppose this is one organic acid. It dissociates into A minus H plus. Since organic acids are weak acid, so here you have to use this reversible symbol. This is acid, weak acid. This is its conjugate base. Now remember, if this conjugate base is more stable, then corresponding acid is more acidic. Corresponding acid is more acidic. Because if this conjugate base is stable, it will remain in this form. That means right hand side reaction will take place. So dissociation of acid will take place. It will liberate H plus, means it is more acidic. Now see how to compare the acid strength between two acids. This is ethanoic acid. It dissociates to form this anion and H plus. You know neutral species are more stable, and this is conjugate base of ethanoic acid. CH3 is having plus I effect. So what will happen? It will donate electron density. So here negative charge will increase. That means this species is less stable. Here I am writing it is, this conjugate base is less stable if you compare the stability between this and this. Now here at alpha position of ethanoic acid, one fluoro group is there. It is electron withdrawing. It is having minus I effect. That means here it will pull electron density towards itself. So here due to minus I effect of fluoro, what will happen? Here this conjugate base is more stable. If conjugate base is more stable, what will happen? This acid parent acid will be more acidic. Because if it is stable, so right hand side reaction will take place more and it will liberate H plus. So if it is more stable compared to this, parent acid is more acidic than this. So you can summarize this thing, acid strength is directly proportional to minus I effect. With increasing minus I effect, conjugate base will become more stable and corresponding acid will become more acidic, and it is inversely proportional to plus I effect. So you remember this thing. Now can you compare the acid strength here? Now see here, in acetic acid, alpha hydrogen is replaced by CH3 group, here by fluoro group, and here by nitro group respectively. You know CH3 is having plus I effect, and fluoro and nitro, they are having minus I effect. Now first you have to write the conjugate bases. For this acid, what is the conjugate base? For this one, this is the conjugate base, and for this is the conjugate base. Now distance of these groups from negative charge from this anion is same. So distance wise, distance is same here. Number wise they are same. Everywhere 1 groups are there, so numbers are same. Now what we have to see? We have to see power. Now here it is having, CH3 is having plus I effect, so it will destabilize the conjugate base, and these two are having minus I effect. This will pull electron density and anion or conjugate base will become stable. Here nitro group has maximum minus I effect between these two. So maximum stable anion or conjugate base is this one. If we compare the acid strength, so it will be like this. This is increasing order. Now compare the acid strength of these three acids. First what you have to do, you have to write the conjugate bases. Means you have to remove H plus. You are getting conjugate base. Now see, distance, everywhere what is happening? Here in acetic acid, 1 hydrogen is replaced by fluorine. Here 2 hydrogens are replaced by 2 fluorine. Here 3 hydrogens are replaced by 3 fluorine. So distance wise, distance is same from this anion everywhere. So distance wise it is same. But number wise, here it is having maximum number of group having minus I effect. So group having minus I effect, what will happen? It will pull electron density towards itself. It will also pull electron density towards itself. It will pull electron density towards itself. But since here number is more, so pulling effect will be more here. So anion is more stable. So corresponding acid is most acidic. So decreasing order of acid strength is this one. Here we are considering this factor. Now see here next example, methanoic acid, ethanoic acid, propanoic acid. To compare the acid strength, first you write the conjugate base. Now what is there? Here hydrogen is there, here CH3 is there, here ethyl is there. So plus I effect is increasing in this direction. Ethyl is having more plus I effect than CH3 because here number of carbon atoms are more. So here maximum plus I effect is there. So plus I effect is maximum here. Plus I effect. So conjugate base is least stable here. And corresponding acid is minimum acidic. Corresponding acid is minimum acidic. Then what is the order? It is decreasing in this direction, acid strength. Now see, you have to compare the acid strength of the following compounds. Here see, central element carbon, here nitrogen, here oxygen, here fluorine, all are second period element. Everywhere by removal of H plus we are getting this anion. For example, this is methane. So to check its acidic strength we have to release H plus. So we have to make heterolytic bond cleavage in this direction, and here we will get negative charge on carbon, obviously with one lone pair. So always remember, in a period, negative charge on more electronegative atom is more stable. So between carbon, nitrogen, oxygen, fluorine, this is most electronegative. So along a period from left to right, electronegativity is increasing. So this conjugate base is more stable, then this, then this, then this. So obviously acid strength is increasing in this direction. For these compounds, here bond length between hydrogen and iodo is maximum. Bond length is decreasing in this direction. Since bond length is maximum here, it is most reactive to donate H+. So acidic character is decreasing in this direction. Or you can say in another way that here conjugate bases are, after removing H+, after donating H+, it is forming I-, it is forming Br-, it is forming Cl-, and it is forming F-. Now remember, negative charge on big size atom is more stable in a group. FCl, Bri are in the same group, and its size is increasing in this direction, means down the group. So this is biggest size among these four. So biggest size atom is having negative charge, means it is most stable. So parent acid is most acidic. Acidic character is decreasing in this direction. Now see, between CH3SH and CH3OH, between this and this, which one is more acidic? So here you have to write the structure of conjugate base first. So after removal of H+, we are getting S-, negative charge is on sulfur. Here after removing H+, we are getting this, here negative charge is on oxygen. These are same group element. So negative charge on big size atom is more stable in a group. So this is more stable, therefore corresponding acid is more acidic than this one. Next application of inductive effect is compare the basic strength. Base means which can donate lone pair or which can accept H+, means proton. Now see, I am taking one example. Ammonia, and this one is IUPAC name ethanamine, or common name ethylamine. So between ammonia and ethanamine, which one is stronger base? Both are having lone pairs, so it can donate lone pair, their Lewis base. Ethanamine is stronger base because, now see here, once again I am writing this structure. This is ethyl group, alkyl group. It is having plus I effect, electron releasing or electron donating effect. So ethanamine is strong base because plus I effect of ethyl group increases the electron density on nitrogen atom. So electron donating tendency of it becomes more than ammonia. So which one is stronger base? This one. Next example. Now see, oxygen is having lone pair. This lone pair it can donate. Now see, here this is tertiary alcohol, this is secondary alcohol, this is primary alcohol. Now see here, 3 CH3 groups are there with this carbon, so they are having plus I effect. Here 2 CH3 groups are there having plus I effect, and here one which is having plus I effect. So due to maximum plus I effect here, maximum tendency to donate lone pair of electron is here because electron density on oxygen increases. So this is most basic, then order is decreasing in this direction. Next example. Now see, these three compounds are basic. Nitrogen is having lone pair, it can donate this one. Here one hydrogen atom of ammonia is replaced by CH3 which is having plus I effect. So due to plus I effect, it is increasing electron density on nitrogen. And here Cl group is there. One hydrogen is replaced by, of ammonia is replaced by chlorine. it is having minus I effect, which is taking electron density from nitrogen. So obviously here electron density on nitrogen is decreasing. So this one is most basic, then order is going in this direction, means it is increasing order. With this we have completed inductive effect. Thank you for watching.